We're going to start 5.7 day 1 with some review problems. So we have to solve these equations, state the number and type of roots. The directions aren't very clear. Type means how many real and how many imaginary. So for number 1, the exponent is 2, so it's a quadratic. We've learned 4 ways to solve a quadratic. The easiest way is to factor when possible. So this one's going to be x plus 7 times x minus 3. By the zero product property, if we're multiplying two things together and the result is 0, then one of them has to be 0. So either x plus 7 is 0 or x minus 3 is 0. So either x is negative 7 or x is positive 3. And so we got two answers, which is good because the degree is 2. And both our answers were real. So two real answers, negative 7 and positive 3. Okay, I'm going to let you guys try the even problems on your own because it's kind of repetitive. So for number 3, first thing you should do is take out the GCF. 12 and 100 can both be divided by 4. They also both have an x. So if I take out 4x from 12x cubed, I'm left with 3x squared. 100x divided by 4x is 25x. Actually, just 25. And by the zero product property, either 4x equals 0 or 3x squared plus 25 equals 0. So solving this one, we get x equals 0. Moving 25 to the other side, we get negative 25. Then we divide by 3. Square root both sides. Put plus or minus in front on the right side. The square root of 25, or the square root of negative 25 is 5i. The square root of 3 we don't know, so we have to multiply because we're not allowed to leave a radical on the bottom. So we get plus or minus 5i radical 3 over 3. So we have one answer here, two answers here. So in total we have one real and two imaginary. The degree was 3, so we should have a total of 3 roots. And the imaginary root always has to be an even number. Alright, so for number 5, we're getting into Descartes' rule of signs. So the way Descartes' rule of signs works is you have to count the number of sign changes in the original problem first. So looking at this function, the first term is positive. The second term is also positive. The third term is negative. And the fourth term is negative. So if I'm counting the changes, it starts positive, that's not a change. It stays positive, and then it changes to negative. So during that sequence, it only changes once. So what that means is the number of positive roots is going to be 1. Alright, to figure out how many negative roots there are, you have to plug in negative x for x. So that is, you have to find f of negative x. The easier way to do this is to look at the exponents if the exponent is odd, then it will be the opposite of what it was. If the exponent is even, it'll stay the same. All right, so the next one is x to the first. That is odd, so it'll be the opposite of what it was. And then if it doesn't have a variable, it's going to stay the same. So just imagine if I had plugged in negative x there. Negative x times negative x times negative x. Well, that would be negative. So that would have gone from positive to negative. If I had plugged in negative x there, it would go back to positive because negative x times negative x is positive. So if the exponent is odd, change it. If it's even, keep it the same. Okay, so this one starts negative. That's not a change. But then it changes to positive. So that's one change. Then it stays positive. And then it changes to negative. So in this span, there are two changes. Starts negative. Then it changes to positive. It stays positive, but then it changes back to negative. So there are two sign changes. So the number of negative roots is going to be 2 or 0. So the reason I write or 0, you are allowed to decrease the number by an even number. Now I didn't do that for the positive list because if I decrease 1 by an even number, then that takes me to negative 1, and that doesn't make sense. You can't have negative 1 positive roots. So you are allowed to decrease it by an even number. Alright, so the way I want you to display your answers is actually with a table. I know the book doesn't do that, but it'll make it easier for us to grade. So there are 3 possibilities: positive roots, negative roots, imaginary roots. There's actually a 4th possibility. So besides positive, negative, and imaginary, a root could also be 0, which is a special case that we'll see on number 7. Alright, we have 2 possibilities here. It could be 1 positive and 2 negative, or it could be 1 positive and no negative. 1 positive and 0 negatives. The degree from the original problem was 3, so the total has to be 3. So if I have 1 positive and 2 negative, that means we have 0 imaginary. That makes a total of 3. And if I have 1 positive and 0 negative, then I have 2 imaginary, also making a total of 3. So the answer is just going to be your table. Okay, so for number 7, we're going to count the sign changes. So starts positive, then it changes to negative, that's 1, stays negative, changes to positive. Okay, so there were 2 changes in that polynomial. So I write 2 or 0 because I'm allowed to decrease by an even number. So let's say, for example, we got 5 sign changes. Then we would say 5 or 3 or 1. You can always go down by an even number until it doesn't make sense anymore. Alright, let's find the number of negative roots. So this one will stay the same because the exponent is an even number. This one will go to positive. This one will stay the same. And this one will go to negative. So the odd exponents became different. They became the opposite of what they were. The even ones stayed the same. Okay, counting the sign changes. It was positive. It stayed positive. Changed to negative. That is 1 sign change. Okay, so I'm going to say I'm going to make my table And this one has a special case, positive, negative, imaginary, and there's also a 0 root on this one. Right. The reason I could tell 0 is a root, if you look at the original problem, you were taught to always check for a GCF first. So looking at the original problem, x goes into every single term. So if we take out an x, we can see that 0 would be a root of this polynomial. So we know that there is one root that is 0. And now let's go through our possibilities. It could be 2 positive and 1 negative, or it can be it could be 0 positive and 1 negative. And we confirm that there is one root that is just 0. Okay, remembering that the total has to be the degree. We already have 4 total in the first row, so that would leave 0 imaginary. In the second row, we only have 2 total so far, so we would need 2 imaginary. Okay, go ahead and try the even problems on your own now.